price elasticity of demand, or PED, measures exactly how sensitive consumers are to a change in price. It tells us the precise rate at which the quantity demanded will shift when a price tag goes up or down. We calculate this sensitivity using a specific formula: the percentage change in quantity demanded divided by the percentage change in price. Applying this to a past paper, if demand for coffee drops, we slot those percentage values into our equation blocks, resolving to -0.3. Firms rely on this resulting number to set their strategy. It allows them to predict how their specific market is likely to react before they ever adjust a price. We can also use this formula to work backwards. In another exam question, a government wants to reduce cigarette consumption by exactly 10%, and the PED is estimated at 0.5. Our goal is to find the required price change. Examiners point out a frequent trap here. Students often incorrectly invert the formula, dividing the price by the quantity, which generates a completely wrong answer. To avoid that trap, strictly maintain the structure. We take our target 10% reduction in quantity demanded and divide it by the known PED of 0.5. This calculation tells us the government must raise prices by 20%. This mathematical reversal provides policymakers with a data-driven way to estimate the specific tax increases needed to reach a consumption or revenue target. Next, let's analyze a question featuring a car producer whose estimated PED is -2.0. Because -2.0 is mathematically less than 0, many students immediately assume this represents inelastic demand. That is a mistake. The negative sign only represents the inverse relationship between price and demand, meaning as one goes up, the other goes down. When classifying elasticity, the minus sign must be entirely ignored. By looking solely at the absolute size of the figure, we see it is 2.0. Any value greater than 1 means consumers are highly responsive to price changes, and therefore demand is elastic. Let's step away from the math and look at comparative analysis. This 6-mark question asks why the PED for luxury chocolates differs from salt. Pause the video here and see if you can recall the determinants of elasticity. Luxury chocolate has elastic demand. It has many close substitutes, it is a luxury want rather than a necessity, and it takes up a larger proportion of a consumer's income. Salt sits on the opposite end of the spectrum. It has no close substitutes, it is a physiological necessity, and it accounts for a tiny fraction of a consumer's total budget. A product's elasticity is dictated by consumer necessity and the availability of alternatives. These factors make chocolate demand reactive to price shifts, while salt demand remains resistant. This brings us to question 5, which asks us to analyze the commercial advantages of selling a product with price inelastic demand. The core rule of inelastic demand is that raising prices will cause only a less than proportionate drop in the quantity demanded. Because consumers cannot easily switch to substitutes, price and total revenue will move in the exact same direction. If a firm raises its price, its total revenue will rise alongside it. This relationship allows a firm to forecast its income more effectively. When revenue and price move together, the business can plan for future costs with greater certainty. Ultimately, PED helps a firm determine if a higher price will result in higher total revenue or if the loss of customers will outweigh the gain in price. To wrap up, keep these 3 examiner warnings in mind. Never invert the PED formula, always ignore the negative sign when interpreting elasticity, and never confuse the determinants of demand with the determinants of supply.
Fundoo Tutor is a personalized learning platform that helps students succeed in Cambridge, IB, and other international curriculums with expert mentorship, structured learning support, and engaging resources.